O- Okay, this evening, everyone. Okay, the first of all, I would to like to say thank you for this program, and thank you everyone to listen me. Yes, okay. I prepared my presentation for year. No, it's not for year, for day. And today I want to present to you. Okay, the first I want to show this is the slide in the computer. Yes,
Yes, we can see
I
it.
use. You can see it. I'm sorry. Okay, when I want to teach this topic in my class, I show this picture. Everyone know what is the picture? Where is in the picture? You can ask. You can answer in your
In the
microphone.
moon.
Yes, in the moon. Yes. Why you know in the moon, right? Not in the Earth. Yes. This is a mission of Apollo 16. Yes. Okay. Do you know the moon is not the atmosphere, right? Do you know? Everyone know. And when the astronaut collect the something from the moon to the Earth, I want to know how do we know that the object is dangerous? How to check its safety? I show this picture and I want to brainstorming of student, and you can use the menti.com for the write your answer for this. When you keep the rocks from the moon come back to the earth, and you must know its safety. You can check how to check. Yes, I want to know how to check. And when you go to Menti, code 413153 and 1, or you can QR code and you write answer. I want to know your answer. Yes. And I switch to the sorry. Okay. Sorry. This code. Are you see it?
Nothing yet.
Oh yes. Sorry. Okay. You see it? The
Yes.
menti.com.
Yes.
Yes.
Yep.
Okay. I want to. I want to everyone please write the answer. Some answer. The rock is safety or not safety? Please write this. How to check its safety? I think if I teach in my school or in my classroom, I think many of the student can answer the not safety and check it by the something. I have you can see my video. I'm sorry. You can see me. Yes, you have a detector, radiation detector in my country have a radiation monitor, and I have not the Geiger-Müller counter. And when I teach, I show something to the student, and I switch my camera again. Yes, you can use uh, you can use stuff from your your mind, and this is a stone from near the school, and you have checked the glass and ceramic glass, and you turn on the detector, and you display or show the student in the classroom. The student can see the sound and the digital number, and it's a radiation. Yes, I want to go to the radiation, the topics. Yes. Okay, and I want to share PowerPoint again. In my PowerPoint, okay, your answer is already. And if you not the Geiger-Müller counter or detector, you can use the video from the YouTube. I select the radioactive stuff, and I want to open your something. Okay, in the slide, you can conclude the rock from the author can emit something to your to you, and it can destroy the cell of the humans. It's dangerous. You can check its safety, and you can teach the radiation of the something what is from that ก็คือ radioactive material or around us. You must learn and live safety with them, and you can use the why and you ask the question to the student why the object can emit something which called its radioactivity. Okay, you can teach the nuclear or the atom of the material is stable. When it's not stable, it can approach or emit something from the atom. You can check its safety by the detector. And in the picture, you can see this is some people use the Geiger-Müller counter check the something. Yes. And the next slide, you can show the atom. Yes. When I example carbon atom, and you can see the carbon atom is the tree. When the atom stable, it's very happy, and not stable, it's unhappy. You can see in the right picture. Okay, because the proton are more than the neutron, or neutron more than the proton. Yes, in unstable. Okay, and you show some picture when radioactive from the atom radiation, you can emit something. Something is many particles, and the 3 particles you can teach to the student: an alpha particle, beta particle, or gamma ray. It is not all particle, is a electromagnetic wave, gamma ray, and this type of the radiation. Yes. In the second topic, you must separate the radiation to the two types. I want to everyone can show your hand when you excuse me, when you think the radio is a non-ionization or ionization, you can use your hand. When you have a non-ionization, you can use the two hand this way. Yes. When you have a ionization, you can switch or you can vibrate. It's ionization. Okay. When I read the ticket radio, you can use the toot or toot. Okay, radio. Please show your hand. Okay, very good. Very good. Microwave. Do you know non-ionization or ionization? Oh yeah, very good. Infrared. Okay. Beta ray. Okay. Ionization. Neutron ray. Do you know? Okay, very good. Okay, when I ask you in all that, you can check the student understand non-ionization or ionization, and you teach something to the video. What is ionization radiation? And you can, I want to show some video. It's 1 minute, yes, to show to you. Oh, I'm sorry. Are you here? Listen.
We could see the video, but no sound.
Oh, yeah, sorry. No sound. Okay.
But it's okay if they're posting in the video.
Okay. Yes. When you finish the video, you can understand the ionization and non-ionization, you can see the meaning high energy radiation give off from the radio material. Non-ionization radiation is a low energy radiation like radio wave or microwave. And you can conclude the student by this picture. Type of ionization radiation is radiation in the ionization is a X-ray and gamma ray, and the electromagnetic electromagnetic wave is a non-ionization. Okay, when the student understand non and ionization, you can show this ionization radiation, and you teach more the alpha radiation, beta radiation, and neutron radiation or gamma radiation. You can teach it in this picture, and you can use this picture to when alpha move to the something and ionize another atom to the electron can loss from the atom, and the atom have an ion to the ion. Yes, and you can use this picture is again. Okay, when the atom unstable, the atom can emit something. The something is or are alpha, beta, and gamma energy or particle. Yes, you can use this picture is again is clearly to understand. And the video too, I want to show you this some of the checks radiation of the some material. You can use the video, and when you use it's very have enough time. You can select the video. Yes, I select the video. I select the video because it's very understand. It's easy to understand and clear up the shield of the alpha, beta, and gamma. And next slide, you can use the. I think I use the name knowledge of the alpha radiation paper. Yes, do you know? I print out the paper alpha radiation. I print out beta radiation, and I print out gamma radiation to students to read with themselves. And when they read, they must understand the something. And if the student can understand, student can walk to me and ask me again, and I teach it again by the lecture, by the something. I want to student learning first. Okay, when the student learning by the knowledge paper alpha, beta, and gamma, you can check the student understand alpha, beta, and gamma in this picture. Alpha, beta, and gamma can move from the paper, aluminum, and lead. Okay, the student can understand the penetration ability of the particle or the something emit from the atom. Yes, and you can use more the particle X-ray or neutron, and you can use this picture. Okay, when you want to finish the class, you can use the next topic in the class. You can ask the question to the student survey or discover the knowledge. When the alpha, beta, and gamma move to the electric field, what happens on the alpha, beta, or gamma? I think students can think something and learn more with themselves to understand it. Okay, I want to show this when the particle into the electric field or the particle move to the magnetic field. What happened? Do you think if alpha, beta, and gamma moving to the magnetic field in this picture? Okay, and the next class you can detail of the what happened in the alpha, beta, or gamma, and you can listen question what is the number 1, what is number 2, and what is the number 3. Student can guess it's it's wrong, it's not serious. Yet the student can guess. Okay, and you ask some question, why? Okay, and magnetic field is the same, the electric field. You can ask, can you guess number 1, what is this? Number 2, what is it? And number 3, what is it? And you question the last question, why? Yes. Okay, when I want to finish in this class, you must check your blank in the correct. Okay, again please, when you have a radio, can you show your hand and you can for the checklist in the correct. I write in the Jamboard and I have no link to you, and I think you can understand. Radio, please again, please. Radio, ionize or non? Ionize or non? None. Yes, very good. Beta ray, ionize or non? Okay, very good. Infrared, none. Okay. Gamma ray and visible ray. Okay, thank you. And when you check the student understand the characteristics of the alpha, beta, or gamma, you can use this picture, and student can heavy mass or light mass, heavy mass, light mass, no mass. You can check the student can understand. Okay, and today I am so happy, and I think we will see you next class. Thank you for this day. Thank you. ขอบคุณครับ
Thank you. Thank you so much, Sharifo.
Thank you.
Okay. So now let's ask Dave for the comments and suggestions and recommendation. Yeah.
Sure.
Hello, Dave.
Very nice, Sab. I really liked the flow of the lecture overall, and I liked how you started with the moon example. So starting with something concrete, really using that inquiry or phenomena-based approach to start the lesson and to get students interested from the beginning. There's a very practical problem about, well, how would you actually know if this was safe or not to handle once you brought it back to Earth? And then expanding from there, all the sources and all the information in the lecture was really good and accurate, so no problems there. And I also liked how you did the extension at the end with, with what you know now, could you actually figure out this charged particle exercise too, just based on what you've learned from alpha, beta, gamma. So I thought it all flowed really well. I liked your example, and I liked your jumping off point for the lecture too. I thought that was really good.
Yeah. Thank you, Dave. Yeah. Habiba?
All right. Very interesting presentation, and I just like to give an applause for when you explain about non-ionizing radiation and ionizing radiation, because this is where the students or public tend to get misconception about it or misinterpret about the meaning of it, because not many people knows about it. So it's good for the teachers to focus on this thing in the classes, right? Thank you.
Thank you, Habiba. How about Rox?
I'd like to comment on the materials that would be used if the lesson is to be implemented. They are very well developed, the Jamboard and the knowledge sheet. I think we call it that. And also questions in the extent part, the one with the magnetic field, require higher order thinking skills from the students. And I like that it relates the lesson to a previously learned concept in another area of science, physics, for example, and it sort of ties things together. So that's a very nice question on how would the charged particle behave in a magnetic field.
Okay, thank you, Rox. And you know, Dave, Rox and I were been discussing about the lesson plan, the lesson exemplar. So I was looking at the lesson exemplar of Seripong, how it was improved, and really you can utilize that Okay, because it was really well crafted. And another one, I like the incorporation of the games. Yeah. So the struggle now when you're doing the online teaching, you just, rather than giving them the Jamboard, you just say, okay, ionizing, you say X-ray, ionizing, non-ionizing. So you give us way to interact also with the teacher. And I like the questioning technique. Okay, you know how you ask questions. You develop the critical thinking skills of our learners. Thank you and congratulations. Now let's proceed to the next presenter. Yeah. Okay, Dave.
Thank you, everyone.